Hello everybody. Today we are going to discuss another topic, that is motor unit. So, what do you mean by the topic motor unit? To understand this topic, I have already made one diagram here. You can say that this is the cross section of a spinal cord. Okay, this is the anterior aspect of the spinal cord and this is the posterior aspect of the spinal cord. We all know that the motor neuron, they are located in the anterior region of the spinal cord. So I am drawing here one motor neuron. So this red color one, this is the motor neuron, right? It is extending its axon towards the skeletal muscle, and then we all know that this axon terminal will be divided into axon knobs. So these are the axon knobs or axon buttons. All these axons button, they will make synapse with the skeletal muscle fiber. So as you can see here, because this neuron has been divided into 3 axon terminal, it will make synapse with 3 skeletal muscle fiber or 3 skeletal muscle cell. And we all know that this is the region where your neuromuscular junction is going to be formed. So this is the area where your neuron and muscular junction is going to be formed. But neuromuscular junction transmission we are not going to discuss here. That will be discussed along with central nervous system, although it's part of the peripheral nervous system topic, right? Now second thing is that if I draw another motor neuron at the level of spinal cord, suppose I am drawing another motor neuron here, but look at the diagram. This motor neuron has a larger cell body than that of the previous one. So this is a blue color motor neuron. The cell body size is a larger than previous one. Again the same thing, the axon will extend towards the skeletal muscle and it will be divided into axon terminal. But because the cell body size is larger here, the number of axon terminal will also be more. That means this is a large neuron than that of the red color. So because it is forming 4 axon terminal, what it is going to do, it is going to form synapse with skeletal muscle fiber again, but here it will make synapse with 4 skeletal muscle fiber, right? So now I can understand that the whole skeletal muscle, okay, so this is our whole skeletal muscle. So inside this skeletal muscle, multiple muscle fibers are there, but multiple muscle fiber are not supplied by a single neuron. Obviously there are multiple neuron, multiple axon terminal, but if I follow this red color neuron, right, so this red color neuron is supplying 3 skeletal muscle fiber simultaneously. Similarly, if we look at this blue color neuron, this blue color neuron is supplying 4 skeletal muscle simultaneously. So if I stimulate this red color motor neuron, 3 skeletal muscle fiber will contract simultaneously. But if I stimulate the blue color neuron, 4 skeletal muscle will contract simultaneously. This concept is known as the motor unit, means one single axons and the number of skeletal muscles supplied by it is known as a single motor unit. So if I write down a definition of motor unit, okay, so obviously you are understanding that motor unit means it is a single axon. This is the definition, single axon and the number of skeletal muscle fibers supplied by it, number of skeletal muscle fibers supplied by it, right? Okay, so this is the definition of a single motor unit, means this single axon, this is red colored axon plus this 3 skeletal muscle fiber, they are forming a unit. Okay, this is motor unit. So in this diagram what I have made already, you can find out that 2 motor units are there. 2 motor units are there. The red color is the smaller size motor unit and the blue color is the larger size motor unit. So your MCQ is that in our body, the smallest size motor unit is found in which skeletal muscle, right? So please remember, if your motor unit size is smaller, then you require those motor unit for fine movement. Like for example, when I am writing, there is fine movement of my finger. When I am moving my eyeball, there is a very fine adjustment of the eyeball movement. So please remember, this fine movements require small size or smallest size motor unit. So smallest size motor unit is present at the level of extraocular muscles, right, as well as the small muscles of finger, small muscles of your fingers, right. So these lumbricals and this interossei, those muscles are the smallest size motor unit. It is said that the innervation ratio of this, so what I am saying, it is said that the innervation ratio, okay, of this smallest size motor unit is 1:3:6. What is the meaning of this? One single axon is supplying 3 to 6 skeletal muscle fiber. That is the meaning of innervation ratio. So basically the motor unit and innervation ratio is basically the same thing. Innervation ratio is the axon is to skeletal muscle fiber supplied by it is the ratio, and motor unit means it is a single axon and the total number of skeletal muscles supplied by it is forming a unit, right. So smallest size motor unit is extraocular muscle and small muscles of finger with the innervation ratio of this. So obvious question will arise that largest size motor unit, okay. So largest size motor unit is located in the muscles of the lower limb, okay. So particularly the muscles of leg, okay, that is the gastrocnemius muscle. Gastrocnemius muscles, they contain the largest size motor unit and also the muscles on your back. So the largest motor unit means these muscles are not required for fine movement, but they require for gross movement only. Like for example, when I am sitting, my back muscles, they are contracted simultaneously, large group of back muscles, okay. Fine adjustment, fine control is not required there, but for writing with this finger you require fine adjustment. So largest size motor unit is located at the muscles of the gastrocnemius muscle as well as the muscles of the back. The innervation ratio here, okay, so here the innervation ratio is 1:600 to 2000. 600 to 2000 means one single axon supplies 600 to 2000 skeletal muscle fiber at the level of this gastrocnemius muscle, at the level of your back muscles. So this is the smallest size motor unit and largest size motor unit. These two concepts are very, very important, right. Now next you look at, again we are at the diagram of this motor unit. So suppose I want to contract this skeletal muscle. So this is my skeletal muscle, right. I want to contract this skeletal muscle to do some job. Suppose I want to lift one glass of water from the table. So I am contracting this biceps muscle. So this is a voluntary contraction. Voluntary contraction means the signal will reach from brain. So what I am saying, the brain will stimulate this motor neuron, right. So brain means motor cortex I am talking about. So the brain is stimulating this motor neuron, and because the motor neuron is stimulated, the skeletal muscle fiber will contract and you will be able to do the job. Now if I ask you, when the brain is stimulating both of these neuron, which neuron will be activated first? Is there any principle, is there any rule, or there is random activation of motor unit? Getting my point? Small size motor unit will be activated first or large size motor unit will be activated first? This is the question. Remember, this is the same principle which we apply in our day-to-day life. Suppose you have two person, one is a lean and thin person and one is a very big fatty person, right. You want to do one job, okay. So whom will you ask to do the job? Suppose you want to lift the glass of water from the table, small job. So the big fat person or the lean and thin person, whom you will ask? The lean and thin person, obviously, because he will do the job rapidly, okay, and he is least fatigable. But the fat person, he is more fatigable, he is lazy kind of person. So that's the same principle is applied in our body also, okay. Whenever brain is stimulating both of these neuron, always remember that the smallest size motor unit will be activated first, followed by larger, followed by largest. So this principle is known as recruitment principle of motor unit. Very, very important for your MCQ. This is known as recruitment principle of motor unit. Recruitment of motor unit, right? So what I told already, I told that first the smallest size motor unit will be activated, smallest size, followed by large motor unit, followed by largest motor unit, okay. So first the brain will activate the smallest size motor unit, okay. So obviously if you activate the smallest size motor unit means few muscles fiber will be activated. So if that force of few muscle fiber is adequate to do your job, then the larger motor unit will not be activated. But suppose the smallest size motor unit is not adequate to do the job, then you are going to activate the larger motor unit which is present nearby, and even if that is not sufficient to do the job, then the largest motor unit will be activated, right? Similarly, when you want to give rest to this motor unit, suppose your job is done, you have already lifted the glass of water from the table, now you want to give relaxation to this motor unit, rest to the motor unit, that is known as de-recruitment principle of motor unit, de-recruitment of motor unit. Remember, de-recruitment occurs in the opposite direction, means the big fat man, he is lazy and he is easy fatigable, so give rest to the big fat man first. So that way the body will also do the same job, that the largest motor unit will be de-recruited first, followed by larger motor unit, followed by large motor unit, and at the last the smallest motor unit will be de-recruited. So largest, okay, followed by larger, large, and then smallest. So I can understand that the motor unit which is recruited first, that is de-recruited at the last. From these two I can understand easily. So what I am writing here, very very important, that recruited first, okay, recruited first is de-recruited last, de-recruited last, right? This principle was first time discovered by a scientist, and according to the name of this scientist, the principle is known as Henneman, Henneman, Henneman's size principle of motor unit recruitment. This is known as Henneman's size principle of motor unit recruitment. So Henneman for the first time told that at the level of spinal cord, suppose you have thousands of motor unit, body will try to activate the smallest motor unit first. If your job is done, then nothing. If your job is not done, then the larger motor unit followed by largest motor unit is going to be activated. During de-recruitment, you have to give relaxation to the largest motor unit first, followed by the smaller and the smallest. So this is known as the Henneman size principle. Very very important, very very crucial for your MCQ purpose, remember. Now next thing is that, okay, so now we understand that when you want to do more work with the skeletal muscle, what you are doing, you are activating more and more motor unit. So more motor unit recruitment means more number of fiber is activated, more force production at the level of skeletal muscle. Is there any other way to increase the force generation by the skeletal muscle apart from this recruitment of more motor unit? Getting my point what I am saying? So I am asking a question to you, that what are the different way by which skeletal muscle increases force production? So force production, okay, force production, increase force production by skeletal muscles. What are the different ways by which skeletal muscle increases force production? Could you recall the previous session and tell me, I told you during length tension relationship discussion that force generated by the skeletal muscle depends on the number of actin myosin cross bridge. I told you already, okay, more the actin myosin cross bridge in number, more will be the force production. So at the molecular level, at the sarcomere level, if you look at, then you will find out that increase in number of cross bridge, increase in number of cross bridge increases force production by the skeletal muscle. This principle we have already understood, right? Second, just now we have understood another one, okay, Just now we have understood another one, that is increase number of motor unit recruitment. Number of motor unit activation or recruitment, right? This increased number of motor unit recruitment is also known as multiple fiber summation. This is also known as multiple fiber summation principle. Okay, so we know this. Summation means it is addition of force. So whenever you are recruiting more and more number of motor unit, you are adding more and more number of fiber which are contracting simultaneously. That's all. So what you are doing, you are adding up the force of multiple muscle fiber, and that's why this is known as multiple fiber summation principle or increased number of motor unit. The third way of increasing force production by the skeletal muscle is increase frequency of motor unit activation. So this is now we are going to discuss. So increase frequency of motor unit activation. What is the meaning of that? Meaning, if you stimulate only one motor unit, now you are stimulating that motor unit with a higher frequency, means again and again you are stimulating the same motor unit. That is the meaning of increased frequency of motor unit activation. Again and again you are stimulating the same motor unit. What is going to happen? One thing will happen, that is known as the frequency summation. So this is known as frequency summation principle of motor unit. Means if you increase the frequency, again there will be increase in force generation. That is known as the increased frequency of motor unit or frequency summation principle of motor unit. So to understand this last part, understand this last one, that is the increased frequency of motor unit, we have to take help of one experimental scenario, and believe me, that experimental scenario is very important, particularly for INI set type of examination, right? So try to understand very carefully. Suppose this is one nerve, okay, which is supplying one skeletal muscle. So this is your skeletal muscle, right? Okay, so this is skeletal muscle. So I am stimulating this nerve, or neuron. So this is the point of stimulation. So whenever I will stimulate this neuron or nerve, what is going to happen? First, the action potential will be generated here. Then that action potential will travel down through this nerve. Then that action potential will cross this neuromuscular junction. Then after crossing the neuromuscular junction, it is going to stimulate the sarcoplasmic reticulum calcium release, and then calcium will bind with troponin C, and then the sarcomere will contract. That means after all this thing, then this muscle is going to contract, and whenever the muscle is going to contract, it is going to produce some forces, okay, and that forces is known as increased tension generation by the muscle. Getting my point? So very simple, what I told, that whenever you stimulate one nerve which is connected with the muscle will contract, it will generate some force, and then the muscle will relax. Contraction followed by relaxation. Very simple. If I graphically record this contraction and relaxation of the muscle, I am not recording the electrical activity of the muscle, I am not recording the action potential of the neuron, I am recording this force generation by the muscle, I am recording this tension generation by the muscle. So what I am going to do, okay, I am going to draw a plot, okay. In this plot, the x-axis is the time axis, and in y-axis is the force or the tension generated by muscle, So whenever I am giving a stimulation on this neuron, do you think that immediately the muscle will contract? Answer is no. Because if you give stimulation on this neuron, the action potential will first travel down, then it will cross the neuromuscular junction, then molecular mechanism will happen inside the muscle, and then the muscle will contract. Means after this stimulation, there will be a gap of a time, there will be a time gap, and then the muscle will start contraction. So whenever it is contracting, it is increasing the force generation, and then the muscle will relax. So I can easily understand that this green color part is the relaxation, of the muscle, the force or the tension is decreasing, and this upward direction curve, this is nothing but contraction of the muscle, contraction of the muscle. This recording is known as recording of simple muscle twitch. This is known as simple muscle twitch. Getting my point? This is simply known as SMT. So if you stimulate a muscle only once, muscle will contract followed by it will relax. That is simple muscle twitch. Twitch. Only one contraction, relaxation. That's all. So simple muscle twitch is nothing but contraction followed by a relaxation. Now, normally in skeletal muscle, the duration of this simple muscle twitch is around 100 millisecond. This can be an MCQ in future, so try to remember 100 millisecond. Now within this 100 millisecond, first 10 millisecond is this period where actually the muscle is not contracting, but the action potential is traveling down the neuron, then crossing the neuromuscular junction, then molecular mechanism. This period is known as LP, that is the latent period. So latent period, okay, that is the LP, is generally 10 milliseconds. So within this 100 millisecond, okay, latent period is 10 millisecond. Simple muscle twitch includes the latent period also. Then if I measure the duration from the onset of contraction up to the peak of contraction, then this period will be known as the contraction period or CP. Okay, so the CP or the contraction period, right, that is a CP, is generally 40 millisecond. And obviously the later half is nothing but the relaxation period, that is the RP. So RP is a little more than that of the contraction period, that is 50 milliseconds. So combination of these three duration is nothing but the total duration of a simple muscle twitch, and that is 100 millisecond. Right. So now you got to know that what is the meaning of simple muscle twitch. Now my mood is that I am going to stimulate this muscle multiple times. Okay, I am in a very good mood and I want to see that if I stimulate this muscle multiple times, what is going to happen. Simple, right? So what is going to happen, we want to understand that, but with the help of a diagram. So this is the graph, this is the time axis, and this is the tension axis. So this arrow indicate this is the stimulus point. This is the first stimulus, right? So whenever I have given one stimulation, there is a small latent period followed by contraction and followed by relaxation, right? So as soon as the muscle is relaxing, I am giving the second stimulus here. So second stimulus is falling just after the relaxation. So what is going to happen? There will be a second contraction obviously. Now this second contraction height is larger than that of the first contraction, right? So please note down that if you give two consecutive stimulus, one and second stimulus, okay, two stimulus are given simultaneously, but you note down that second stimulus is given just after the relaxation of the first stimulus. Then I am finding out that the height of contraction of the second stimulus is more than that of the previous one. This increased height of second contraction is known as beneficial effect. Beneficial effect. So this is a kind of summation only. Two stimulus, two contraction are merging with one another. That's why the increase in height. But this increased height is known as beneficial effect. This is beneficial effect. Okay. So what do you mean by beneficial effect? Right. Note down. The beneficial effect is due to increased calcium in the cell cytoplasm. This is due to increased calcium in cytoplasm of the skeletal muscle. So how the calcium will increase? Note down. So this is sarcoplasmic reticulum. Try to recall your skeletal muscle contraction principle. Okay. So whenever you have given the first stimulus, some of the calcium is already released from the sarcoplasmic reticulum by RYR channel, right? Now, to mop up this calcium into the sarcoplasmic reticulum again, you require the help of pump which is known as the Sarca pump, sarcoplasmic endoplasmic reticulum calcium ATPase. This mopping up of calcium into the sarcoplasmic reticulum again require some time. By this time, if you give a second stimulus, okay, suppose the calcium is not mopped up completely from the cytoplasm. During this period, if you give a second stimulus, so some calcium is already present in the cytoplasm, right? Some calcium is already present, and you have given a second stimulus, so further calcium will be released into the cytoplasm. So total amount of calcium during the second stimulus will be larger than that of the previous one, and that's why the height of contraction of the second stimulus will be more than that of the previous one. Getting my point? So I can understand that the second stimulus is getting benefited by the first contraction. What benefit it is getting? The second stimulus is getting the calcium, some reminder of calcium which is coming from the first stimulus. This is known as the beneficial effect, and due to beneficial effect, the height of second contraction is more than that of the first contraction, right? Now, if I go on giving stimulation again and again, so now just after relaxation of the second, I am giving a third stimulus here. So what will happen? Again there will be increase in height. So the third contraction height is again more than that of the previous one. Again I have given another stimulus here. Again there will be the fourth contraction, the height is more than that of the previous one. Now if I give another stimulus here, again there will be another contraction, but this contraction height will be same with that of the previous one. That means if I ask you how long this increased height will continue to rise, answer is only 4 times than that of the first one. So you can understand here. So if this is the first simple muscle twitch, this is second, this is third, and this is fourth. So continuous height increment is going on up to the fourth one. After that fourth one, no further increment of height is possible. So if I ask you that what is the maximum tension generated by this multiple stimulation, maximum tension, that is the 4 times than that of the simple muscle twitch, right? 4 times of simple muscle twitch. Getting my point? After that, whenever you give multiple stimulus, the further height is not going to increase. There will be equal height of all the contraction. So now if you look at this curve, what you are finding out? You are finding out that there is gradual increase in height in a step-by-step fashion. So this is typically looking like a staircase or trapeze. That's why this kind of gradual rise of height of contraction is known as staircase phenomena or trapeze phenomena, TREPPE. Remember that although we are discussing the skeletal muscle, this trapeze phenomena or this staircase phenomena is also seen in cardiac muscle. But for cardiac muscle, we particularly use this term trapeze, and for skeletal muscle, we particularly use this term staircase. Otherwise, there is no difference between this phenomena of staircase and trapeze. Okay, so staircase and trapeze, what is the basic principle I have to remember? That if you give multiple stimulation to a muscle, there will be gradual increase in height of contraction due to more amount of calcium available in the cytoplasm. This gradual increment of height of contraction is known as staircase phenomena or trapeze phenomena. Getting my point? So staircase or trapeze phenomena, I hope all of you understood. Now, if I give multiple stimulation but with a higher frequency than this, right? So now I am going to draw another curve. Okay, so just hold on, I am drawing another curve. Okay, so in this diagram I am going to give multiple stimulation in a similar manner, but the frequency of stimulus is more than that of the previous stimulus, right? So I have given a stimulation here, I got one simple muscle twitch here, right? Now when this muscle is going for relaxation, suppose I have given the second stimulus in such a way that before the complete relaxation of the muscle, the second stimulus is coming. So what will happen? The second contraction will start from here only, okay, and again there is increase in height of the second contraction. Now the second contraction is going for relaxation, but before complete relaxation I have given the third stimulus. Again the third contraction will start from here, again there will be increase in height, and now the third contraction is going for relaxation, but before the complete relaxation I have given another stimulus. So now the fourth contraction is coming up, okay, and again before the relaxation of the fourth contraction if I give another stimulus, okay, this way if I continue, then there will be multiple contraction without proper relaxation like this. Getting my point? Again you are finding out that there is increase in height in a step by step fashion, in a staircase fashion. But what is the difference of this graph with the previous one? If I look at that, in the staircase or Trevi phenomena, every contraction is reaching at its relaxation point, complete relaxation point. Every contraction is touching the baseline. Baseline means every contraction is coming to its full relaxation, then I am giving the next contraction, right? But in this curve, okay, incomplete relaxation is happening, okay, incomplete relaxation is happening, although there is increase in height, okay, in a step by step fashion. But here I can understand that in this diagram there is incomplete relaxation, incomplete relaxation. That's why this is not known as Trevi phenomena or staircase phenomena, rather this is known as incomplete titinous generation. So this is known as incomplete titinous generation. So this is known as incomplete titinous generation in the skeletal muscle. Getting my point? So please note down. So staircase Trevi and incomplete titinous, in both there is gradual rise in height, and the maximum height of contraction that is possible 4 times than that of the simple muscle twitch. But the difference is that staircase means every contraction is reaching to the baseline, means full relaxation, but in incomplete titinous there is incomplete relaxation. Now if I raise the frequency of stimulation more than that of the incomplete titinous also, okay, so what I am doing now I am rising the, okay, so now again another graph, okay, now here I am raising the frequency of this stimulus more. So what will happen? So whenever I am giving one stimulus, there will be a simple muscle twitch like this, right? But I am giving so high frequency stimulus that the second stimulus is falling within the contraction period of the first. The second stimulus is falling within the contraction period of the first stimulus. Getting my point? This is the bottom line. So what will happen? I can easily understand that the second contraction will start from here. So the second contraction is coming up. Even before the starting of relaxation, I have given the third stimulus. So the third contraction will start from here. Again the third contraction is going. Even before the starting of contraction, I have given the fourth stimulus. So the fourth contraction is starting from here. Again the height is rising. Again the same thing, before complete relaxation I have given the fifth stimulus. So what will happen? Now there will be a sustained contraction without any relaxation, because after 4 times there is no further rise of height. So what will happen? After this fourth, if you give multiple stimulus, then there will be a sustained contraction without any relaxation. So this part indicate this is a sustained contraction without any relaxation. So I am not going to get this part of the curve. I am not going to get this part of the curve. Okay, I am only going to get a curve where there is increase height up to 4 times, and then there is a sustained contraction without any relaxation. This is typically known as complete titinous generation. This is typically known as complete titinous generation. So what you understood so far is how to generate a complete titinous. So complete titinous generation means you require a frequency which will be very high, and the frequency should be in such a way that every stimulus is falling within the contraction period of the first stimulus. That's why there is a very famous question in INI set type of examination, that is, what is the formula, how to calculate this titannizing frequency of stimulus. How to calculate? The formula is 1 upon contraction period of the simple muscle twitch. So I told you already how to calculate the contraction period duration. So 1 upon contraction period, this is my formula. What is the meaning of this? 1 means this is 1 second. 1 second means we all know that is 1000 millisecond. So 1000 millisecond upon your contraction period duration in millisecond, if you put, then you are going to get a titannizing frequency of a skeletal muscle. Suppose I have given you a simple muscle twitch where I already told you the typical contraction period duration is 40 millisecond, right? If I want to calculate the titannizing frequency from this simple muscle twitch, then it will be 1, that is the 1000 millisecond upon your 40 millisecond. So this is nothing but 25 hertz is the titannizing frequency. Means if you give a simple muscle twitch like this, suppose this is my simple muscle twitch with a contraction period of 40 millisecond. So if I give a frequency of 25 hertz, means 25 times stimulation within 1 second, then obviously I can easily understand that the distance between these two stimulus will be only 40 millisecond. So one stimulus, first stimulus, second stimulus, third stimulus, every stimulus is falling within the contraction period of the simple muscle twitch, and you will get a sustained contraction, that is nothing but titanous formation or complete titanous generation, right? So please note down this formula of titannizing frequency calculation, 1 upon contraction period. Now why we want to understand complete titanous formation? Now you come back to the motor unit and force production by the muscle here. We have started our discussion from here, right? So I told you how a skeletal muscle can increase its force production. I told you first that increase number of cross bridge formation, second increase number of motor unit recruitment, which is known as multiple fiber summation, and third I told you frequency summation, means if you increase the frequency of motor unit stimulation, then also there will be increase in force production, that is known as frequency summation. Now you can understand that with this experiment, if you give multiple stimulation to a single motor unit, so this is a single motor unit, you are giving multiple stimulation, what you are getting, there is gradual increase in height of contraction. That means the muscle is producing increased force because of multiple stimulation only. Same motor unit, your motor unit recruitment is not there, but you are giving more stimulation and muscle is producing more and more forces. So this is known as frequency summation principle, or increased frequency is rising the force production by the muscle, right? So now the whole picture is that whenever your brain is stimulating some skeletal muscle, first the small size motor unit will be recruited. First the smallest size motor unit will be recruited, right? Then the brain will increase the frequency of this motor unit, and then the brain will assess that after increasing this frequency, whether the force production is adequate by this muscle or not. If not, then the larger motor unit is going to be activated. Getting my point? So first the brain will take the smallest size motor unit and it will stimulate the motor unit in such a way that it generate a complete tetanus. So complete tetanus means we know there will be a sustained contraction and the force production is maximum. So the brain will assess that whether this force is adequate to do the job. If the answer is yes, then no further action. But if the answer is no, that the force production is not adequate, then you recruit further motor unit and again you stimulate that motor unit in a titannizing frequency, so that again it will generate a maximum force, and again you assess that whether the force is adequate or not, and then if not, then you stimulate further. So this way the brain is activating more and more motor unit in a titannizing frequency. So whenever you are contracting this muscle, suppose I am contracting my biceps muscle from this position to a complete flexed position, there is contraction of the biceps muscle, there is contraction of the multiple motor unit. If I ask you what kind of contraction is happening inside the motor unit, Trapi, incomplete titinous or complete titinous. If the biceps is contracting with formation of this incomplete titinous, then there will be a jerky contraction like this. If the biceps is contracting with a simple muscle twitch, then only one contraction followed by relaxation. But we know that whenever I am moving my arm like this, there is a sustained tonic contraction of the biceps muscle without any relaxation in between. That means the biceps or any muscle, whenever you are contracting your muscle, what kind of contraction is happening inside your muscle? There is complete titinizing contraction. Getting my point? So that is the beauty, that in our body, most of the cases the contraction occurs in a complete titinizing fashion. So when the brain is stimulating a skeletal muscle, it will stimulate with a highest frequency so that it produces a complete titinous and a sustained contraction will occur. That's all. Okay, so this is all about your motor unit and basic principle of motor unit. Now some applied aspect of motor unit, right? So we have already understood this diagram, that if this is the cross section of a spinal cord, right? So this is one motor neuron and this is forming a motor unit, right? And if I draw another motor neuron, so this is a larger motor neuron, right? And it will form a larger motor unit, right? So all this motor neuron will ultimately supply the skeletal muscle fiber. So these are the skeletal muscle fiber, right? Okay, and I told you already that suppose this is your skeletal muscle. Okay, so whenever you stimulate any of the motor unit, okay, suppose I am stimulating this red color motor unit, okay, stimulating here. So what will happen? This two muscle fiber will be stimulated. Two muscle fiber will produce action potential. Now if I place a electrode on the surface of this muscle, suppose I have placed one electrode and one active electrode and one passive electrode. So this is the reference electrode, and in between these two I have connected one voltmeter. Okay, in between these two I have connected one voltmeter. I want to record the voltage. So whenever I am stimulating this red color motor neuron, two muscle fiber will produce action potential, right? So this is a part of the motor unit, means I can understand two muscle fiber of the same motor unit will be activated, they will produce action potential. In this recording electrode, I am going to get a potential that will be known as motor unit potential. So motor unit potential is nothing but it is the summated version of the action potential which are generating inside the muscle fiber within the same motor unit. That's why it is known as the motor unit potential. Okay, potential of a single motor unit. So motor unit potential is nothing but summated version of action potential only. Similarly, whenever you stimulate this green color neuron, okay, again the same thing will happen, the motor unit potential will be generated. Now we all know that if you keep this electrode on the surface of the muscle, you are going to record the motor unit potential of multiple motor unit, because whenever this muscle is contracting, okay, multiple motor unit inside the muscle is already activated. So if you place this electrode on the surface of this muscle, you are going to record the activity of the muscle, that is known as EMG, that is electromyography. And electromyography is nothing but it is the summated version of all the motor unit potential that are generating inside the skeletal muscle. So whenever your skeletal muscle is contracting, there are activation of multiple motor unit, and all the motor unit is producing motor unit potential. Summated version of all this motor unit potential is nothing but your electromyography or electrical activity of the muscle. Got it? So motor unit potential is summated version of action potential, and EMG is summated version of multiple motor unit potential, right? Now the combination of all these axons, okay, so this is the multiple axon, okay, multiple axon will form a bundle, and that is nothing but nerve. We have already understood this concept. So nerve is nothing but bundles of multiple axon. So this nerve is nothing but a motor nerve, right? So this nerve is nothing but a motor nerve, okay. This motor nerve is also known as the multiple axon, okay. multiple axon will form a bundle, and that is nothing but nerve. We have already understood this concept. So nerve is nothing but bundles of multiple axon. So this nerve is nothing but a motor nerve, right? So this nerve is nothing but a motor nerve. Okay. This motor nerve is also known as lower motor neuron. This is also known as lower motor neuron. What is the meaning of that? Lower motor neuron concept you will understand in detail in central nervous system, but for the time being you remember the motor neuron which is supplying the skeletal muscle, okay, which has started from the level of anterior region of the spinal cord up to this neuromuscular junction. The same motor neuron is also known as lower motor neuron. In resting condition of the muscle, try to listen what I am saying. In resting condition of the muscle, okay, suppose this muscle, okay, just allow me some time. Suppose this muscle contain 1000 motor unit, right? 1000 motor unit. Within this 1000 motor unit, in resting condition, some of the motor unit will always remain in an active state. What I am saying, suppose it contains 1000 motor unit inside this, right? Within this 1000 motor unit, in resting condition, some of the motor units, suppose within this 1000, okay, 100 motor unit are active in resting stage. Then after certain point of time, this 100 motor unit will enter into a resting stage, another 100 motor unit will be activated. Then again in the next time, this motor unit will be given rest, another 100 motor unit will be activated. That means what I am saying, even in the resting condition of the muscle also, some of the motor unit are always active. Because of some of the motor units, some of the muscle fiber are active, there will be a partially contracted state of the muscle even in the resting condition, and that is known as the muscle tone. So what is muscle tone? Even in the resting condition, the partially contracted state of a skeletal muscle is known as muscle tone. This is known as muscle tone. So muscle tone is nothing but partially contracted state of a skeletal muscle, and that is due to partial activation of some of the motor unit. How this motor unit is activated? It is activated by asynchronous discharge of this motor neuron even in resting condition. So what is the reason? That some of the motor neuron, they will be discharging, okay, asynchronously, means 100 will be activated first, then another 100, then another 100. This way this activation will continue. This is known as asynchronous discharge of motor neuron even in resting stage. This is the reason of muscle tone generation, right? And I told you that this motor neuron which is producing this asynchronous discharge, they are also known as the lower motor neuron. So if you cut this lower motor neuron, obviously what is going to happen? The muscle fiber is not going to contract, and what will happen to muscle tone? The muscle tone will be severely decreased. That's why we know that in case of lower motor neuron disease, the muscle tone decreases to a very, very high level. There will be decrease in muscle tone. This is the reason, right? Now, during this lower motor neuron disease, there will be another phenomena. What is that? In early stage of this lower motor neuron disease, okay, so suppose there is a disease process happening inside this motor neuron, okay, and the disease process in the early stage, okay, your motor neuron is going to die, but it is not dead yet, right? Soon it will die. So in the early stage of motor neuron disease, what will happen? This motor neuron will try to discharge spontaneously, involuntarily, pathologically. this spontaneous involuntary discharge of the motor neuron is happening due to the disease process, that the motor neuron is going to die soon, but before the complete death of this neuron, the neuron is spontaneously discharging, and this discharge is not under your control. So this is a pathological spontaneous discharge of the motor neuron, and whenever this motor neuron is discharging, I can understand that these two muscle fibers which are part of this motor unit, they are also going to contract spontaneously, pathologically, involuntarily. So this involuntary contraction of a single motor unit, so this is part of a single motor unit, because this red color neuron is stimulating here, contracting, stimulated here, what will happen, this motor unit is going to be contracted. So pathological contraction of a single motor unit is known as fasciculations, right? So what I'm I'm talking of fasciculation. So what is fasciculation? I told you that in the early stage of motor neuron disease, due to spontaneous pathological discharge of motor neuron, okay, your answer is involuntary, okay, spontaneous contraction of single motor unit is known as fasciculation. Okay, so here the single motor unit is contracting, and within the single motor unit there may be multiple muscle fiber. So what do you think, this fasciculation will be visible from the surface of the muscle? Answer is yes, because the multiple muscle fiber is contracting simultaneously which are part of the same unit. This fasciculation, it is grossly visible from the surface of the muscle, right? Okay, so this is happening in lower motor neuron disease, but in the early stage. So this is lower motor neuron disease feature, but in early stage. But now suppose the disease in advanced stage and the neuron is completely dead. Now the neuron is completely dead. Or to understand, suppose there is a cut of this neuron, this nerve is completely cut down. Now when this is happening, look at this, look at the this part of the neuron, look at this part of the neuron. Okay, so this is not connected with the spinal cord, so I can understand a diagram like this, that this is the part of the neuron which is disconnected from the spinal cord. It contains the axon terminal like this, okay, and this axon terminal is making synapse with the skeletal muscle fiber, right? So this is a magnified diagram. What will happen? Now this motor unit will not behave like a single unit, because now this is disconnected from the cell body. Rather, there will be a separate phenomena which is going to happen here. Now what will happen? Now this individual muscle fiber, they will start contracting separately. Okay, so now this muscle fiber, if you look at this muscle fiber, they will not contract simultaneously, they are not part of the unit now. Now this individual muscle fiber will contract separately and spontaneously. Individual contraction of the single muscle fiber, single muscle cell is known as fibrillation. So please remember that in contrast to fasciculation, fibrillation is involuntary contraction of, this is involuntary contraction of single muscle fiber. Now question is, why this single muscle fiber is contracting? Because your neuron is already disconnected. So how this muscle fiber is going to contract? Because contraction of the muscle fiber require acetylcholine neurotransmitter. One phenomena happens in this condition. So when the nerve is completely damaged, the acetylcholine receptor will be increase in number on the surface of this muscle. So acetylcholine receptor will be increase in number on the surface of this muscle fiber. So this red color one, there the acetylcholine receptor, they will be increase in number and they will spread throughout the muscle fiber. Normally, the acetylcholine receptor is only present at the neuromuscular junction. But in these cases, when the nerve is completely degenerated, what will happen? This acetylcholine receptor number will increase, as well as the receptor will spread throughout the muscle fiber surface. This is known as upregulation of the acetylcholine receptor. Because of the upregulation of the acetylcholine receptor, the muscle fiber will be more sensitive to acetylcholine. That means even if a single drop of acetylcholine is released from the terminal, single molecule of acetylcholine is released from the terminal, they are going to cause contraction of this muscle fiber. This phenomena is known as denervation hypersensitivity of the skeletal muscle fiber. Denervation hypersensitivity of the skeletal muscle fiber. So I can understand that denervation hypersensitivity is due to increased number of AChR receptor on the surface of the muscle fiber. Because of this denervation hypersensitivity, even if a single drop of acetylcholine is released, that is going to cause contraction of the individual muscle fiber, and that is nothing but fibrillations. Getting my point? So fasciculation is contraction of a single motor unit, and fibrillation is contraction of a single muscle fiber. Both are pathological, both are seen in lower motor neuron disease condition. That's all about the applied aspect of motor unit, right? Now at the end of this chapter, we are going to discuss the difference between skeletal muscle fiber. Okay, so skeletal muscle fiber, right, they are different according to their myosin ATPase activity, according to their contraction and relaxation property and other property. That's why there is a classification of the skeletal muscle fiber. They are known as type 1 skeletal muscle fiber and type 2 skeletal muscle fiber. Type 2 skeletal muscle fiber, right? So this is the classification of the skeletal muscle fiber, type 1 and type 2. Now this type 2 is again divided into type 2b and type 2a. So this is type 2a and type 2b, type 2b, right? Okay. Now you remember type 1 is known as SO type of muscle fiber. So this is known as SO. I'll tell you what is the meaning of SO. So S stands for slow. So this muscle fiber is slow. S for slow and O for oxidative fiber. Okay. Type 2 is known as FOG. This is known as FOG. F stands for, obviously, if it is slow then it will be fast. So this is fast. O for oxidative, okay, and G for glycolytic. Means this muscle fiber will have oxidative property also, as well as glycolytic type of metabolism also. And type 2b, this is known as FG. F stands for, obviously, this is fast, and G stands for, this is purely glycolytic fiber, right? So whenever you look at that, type 1 muscle fiber is known as slow and oxidative fiber. Okay, so what are the property I am going to remember? So I am asking myself why the muscle fiber is slow in nature. Slow means the contraction and relaxation is slow. This is due to two things. One is myosin ATPase, myosin ATPase molecule, which are present on the head of the myosin. What is the myosin ATPase doing? Whenever ATP attaches with the myosin head, it will be broken down by this myosin ATPase. We have seen in the molecular mechanism of muscle contraction chapter. So this myosin ATPase is an enzyme. If this enzyme is slow in nature, so obviously the cross bridge cycling, attachment, detachment, that will also be slower. And second thing, there is a pump, and that pump is known as SERCA. I hope all of you remember. This pump was mopping up calcium from cytoplasm to the sarcoplasmic reticulum. If this mopping up is slow in nature, then again the relaxation will be slow. So myosin ATPase and SERCA pump, they are low in activity, they are very slow. in case of type 1 muscle fiber. That's why the contraction and relaxation of the muscle is slow. And obviously this is very very fast in case of type 2A as well as type 2B muscle fiber. That's why they are known as the fast type muscle fiber, right? So fast oxidative, fast glycolytic, right? So this is the first property. Second property is that if you look at the oxidative metabolism, so the name of type 1 muscle fiber is slow oxidative, means oxidative metabolism is very high in case of type 1 muscle fiber. It will be moderate, okay, it will be moderate in case of type 2A muscle fiber. It will be low, oxidative metabolism is low in case of type 2B muscle fiber, right? So high, moderate, low oxidative metabolism. Now if you look at the glycolytic metabolism, okay, glycolytic metabolism, obvious thing is that glycolytic metabolism in type 1 muscle fiber, that will be low. So it is written in book that glycolytic metabolism is moderate in case of type 1 muscle fiber. In both type 2A and type 2B, glycolytic metabolism is very high. Type 2 and type 2B glycolytic metabolism is very high, right? So now you look at type 1 muscle fiber, okay, how I am going to remember this, okay, SO. So S for slow and O for oxidative. So oxidative is high, glycolytic is moderate. Type 2B, okay, there are two types, type 2A and type 2B. Type 2 is first oxidative, glycolytic, both are there, and here it is only glycolytic type of metabolism. Now what are the other things? Now if the metabolism of the muscle fiber is based on oxidative metabolism, type 1, that is the oxidative metabolism, so you have to supply more oxygen to the muscle, right? So if you want to supply more oxygen to the muscle, what should be the number of capillary density within the muscle? Capillaries density within the muscle, that should be very high. Not only capillary, the content of the myoglobin inside the muscle has to be higher, right, if it is based on oxidative metabolism. Not only that, we know that oxygen utilizing organelle inside the cell is nothing but mitochondria. So mitochondria number should also be high. Not only mitochondria, inside the mitochondria, the enzyme which utilizes the oxygen is cytochrome oxidase enzyme. So cytochrome oxidase enzyme, all this should be very high in case of type 1 muscle fiber, okay, and it should be, okay, high in case of type 2A also, but it should be very low in type 2B muscle fiber, because that is purely glycolytic. If you look at the type 2A also contain oxidative. So this number of capillary, the number of myoglobin, the mitochondria, cytochrome oxidase, all will be very high in type 1. Obviously this will be highest. It will be little lower in case of type 2A, and in case of type 2B it will be very low in amount. Now you tell me, inside the muscle, if your number of capillaries are very high, if your myoglobin are very high, what should be the color of the muscle in comparison to the type 2B? Obviously, this muscle fiber will looks like reddish in color. This will also looks like red in color, but this type 2B will look white in color. That's why all of you know that generally we say that muscle fiber are red muscle fiber or white muscle fiber. So for physiology, you have to remember red muscle fiber means type 1 fiber mainly, although type 2A is also a red muscle fiber, but type 2B is completely white muscle fiber. Now, if your metabolism of the muscle is based on oxidative metabolism, then we know that anaerobic metabolism is going to happen inside the muscle, which is a very late phenomena. And whenever anaerobic metabolism occurs, there will be generation of lactic acid and the muscle fatigue will occur. So if the muscle is based on oxidative metabolism or red muscle, fatigue onset will be a late phenomena. That's why we say type 1 muscle fiber is a fatigue resistance muscle. Right? Fatigue is a late phenomena. Similarly, type 2A, they are also fatigue resistance muscle. Okay, resistant muscle. Okay, and type 2B, that is easily fatigable muscle. Easy fatigable muscle. Getting my point? So this point you have to remember that this is fatigue resistant type 1 and type 201, type 2A, and type 2B is easily fatigable muscle. So now if I ask you example, give me example of this red muscle fiber. Always remember, red muscle fiber means they are fatigue resistance, means whenever you require some action which is long duration, which should be continued for long duration, like for example all our anti-gravity muscle which maintain our posture, like for example I am sitting here for last 1 hour, 2 hour, my muscles on the back, they are maintaining my posture, they are not easily fatigued, right? So muscles on your back or the muscles which are maintaining your posture, they are basically red muscle fiber. But if I do exercise with 5 kilogram weight with the help of this biceps or triceps muscle or these muscles of the hand, they will easily get fatigue after 5 to 10 minutes because they are the predominantly white muscle fiber. So the muscles on your hand, okay, they are white muscle fiber. Getting my point? So this way you have to remember the difference between different types of muscle fiber. Now, whenever you do exercise like this, okay, whenever you do exercise like this, what happens? You know that if you are doing exercise again and again every day, there will be increased bulk of the muscle, that is hypertrophy. Remember, in recent edition of Genong, it is given that whenever hypertrophy is occurring inside the muscle, predominantly type 2 muscle fiber is going to be affected. So please note down that Genong is saying that whenever you are doing exercise regularly, there will be hypertrophy of the muscle. In hypertrophy, which type of muscle fiber is predominantly going to be affected? Type 2A and type 2B muscle fiber is going to be affected mainly, right? And whenever you are not using one muscle for long duration, suppose there is paralysis of one side of the body, the muscle is not used for long duration, there will be atrophy of the muscle. There will be atrophy of the muscle. Right. In case of atrophy, the predominant muscle fiber that is going to be affected is type 1 muscle fiber. So for hypertrophy, type 2, and for atrophy, type 1 muscle fiber is going to be affected. Please note down that every muscles, every skeletal muscle in your body are combination of red fiber as well as white fiber. Pure red, pure white muscle fiber is generally not present. But whenever you are doing exercise, hypertrophy dominantly affect the type 2 fiber and atrophy dominantly affect the type 1 fiber. This is all about motor unit and applied aspect.